Welcome to Core of Space. Our journey is start. Clapperboard title: What is Eta Carinae? The most dangerous star in our galaxy. Far beyond our solar system, hidden deep in the Carina constellation, lies one of the most mysterious, massive, and violent stars in our galaxy. It's called Eta Carinae, and astronomers believe it could explode at any moment. But what exactly is this cosmic monster, and why is it so dangerous? Let's find out. Eta Carinae is a stellar system about 7,500 light-years away from Earth. It's located inside the beautiful but turbulent Carina Nebula, a massive cloud of gas and dust where stars are born and die in dramatic ways. But Eta Carinae stands out for one simple reason: it's huge. This isn't just one star, it's a pair of stars, orbiting each other in a dangerous dance. The primary star is a luminous blue variable, one of the biggest types of stars we know. It's estimated to be up to 100 times the mass of the Sun, and 5 million times brighter. Its companion star is also massive. Around 30 to 80 times the mass of our Sun together, they form a system so unstable that scientists call it a ticking time bomb. The Great Eruption. In the year 1843, Eta Carinae shocked astronomers. It suddenly brightened so much that it became the second brightest star in the night sky, visible even in daylight for a time. But it wasn't a supernova. The star survived. It had a massive outburst, now known as the Great Eruption, and ejected more than 10 times the mass of our Sun into space. That explosion created what we now call the Homunculus Nebula, a pair of giant, expanding lobes of gas and dust, still racing outward at thousands of kilometers per second. Astronomers call this a supernova imposter, because it looked like a supernova, but the star didn't die, yet. Why Eta Carinae is dangerous? Today, Eta Carinae is incredibly unstable. It loses mass through violent solar winds and continues to brighten and dim unpredictably. Scientists believe it's nearing the end of its life, and when it finally goes, it could explode in one of the most powerful types of supernova, a hypernova, or possibly even a parinstability supernova, which could completely obliterate the star. And here's the big question: could this explosion affect Earth? Fortunately, no. At 7,500 light-years away, even a massive explosion won't physically harm us. But it would light up the night sky like we've never seen before, possibly as bright as a full moon. Imagine a star so powerful, so unstable, that astronomers say it could detonate tomorrow, or not for thousands of years. Welcome to the story of Eta Carinae, the most dangerous star in our galaxy. Briefly explaitees, we'll explore what makes it so lethal, what happened in 1843, why it hasn't exploded yet, and what it would mean for Earth when it does. And where it is, 7,500 light-years away, in the Carina Nebula. And remain visible for months. What's next? Astronomers around the world keep a close eye on Eta Carinae using powerful space telescopes. NASA's Chandra X-ray Observatory and Hubble Space Telescope regularly track its behavior. Each year, we learn more about the final stages of these stellar giants. And every time Eta Carinae dims or flares up, scientists wonder: is this it? Is the explosion about to happen? Eta Carinae may not explode tomorrow. Or next year. But when it does, it'll be one of the most spectacular events humanity has ever witnessed. Until then, we watch, and we wait. The 1843 Great Eruption, Eta Carinae's mysterious explosion. In the mid-19th century, a star in our galaxy suddenly became so bright it rivaled Sirius, and for a moment, nearly outshone every star in the sky except the Sun. This event wasn't a supernova. It was something far stranger, and it happened in 1843. This is the story of the Great Eruption of Eta Carinae, one of the most violent stellar outbursts ever observed. What happened in 1843? Eta Carinae, a massive star system located about 7,500 light-years away, underwent a dramatic outburst in the year 1843. Without warning, its brightness surged, becoming the second brightest object in the night sky. Observers at the time were stunned. Some believed they were witnessing a supernova, the explosive death of a star. But what happened was not the end. Instead, the star somehow survived. Astronomers now call it a supernova imposter. A fake death that released an enormous amount of energy, but didn't destroy the star itself. How powerful was it? During the Great Eruption, Eta Carinae ejected an estimated 10 to 45 times the mass of our Sun. That's an enormous amount of material, thrown into space at thousands of kilometers per second. The result was the formation of the now famous Homunculus Nebula, two gigantic lobes of gas and dust expanding outward like a slow-motion explosion. To this day, that nebula continues to grow. And thanks to telescopes like Hubble and Chandra, we can actually watch it evolve, more than 180 years later. What caused it? So what caused this incredible event? Astronomers believe the answer lies in the star's extreme mass, and possibly, in the complex interaction between two stars, or even a triple star merger. The system includes at least one massive luminous blue variable, a type of star known for violent instability. Some scientists think a merger between two stars caused the sudden energy release. Others believe intense radiation pressure and stellar wind simply forced the outer layers to explode. Whatever the cause, the Great Eruption remains one of the most mysterious and powerful non-supernova events in modern astronomy. And the star is still there, alive, unstable, and possibly on the edge of a real supernova at any time. Eta Carinae gave us a warning in 1843. The next time, it might not survive. Why it didn't blow up, the mystery of Eta Carinae. In 1843, a massive star in our galaxy flared so brightly, it became one of the brightest objects in the night sky. Astronomers thought they had just witnessed a supernova, the explosive death of a star. But then, the star survived. How did Eta Carinae unleash so much power, and still remain intact? Why didn't it blow up? Let's find out. It should have been a supernova. The event we call the Great Eruption released more energy than many supernovae. Eta Carinae ejected around 10 to 45 times the mass of the Sun, creating the enormous Homunculus Nebula. The outburst was so extreme that for decades, scientists believed the star had died. But surprisingly, Eta Carinae recovered. It dimmed after the 1850s, and kept shining ever since. So the question remains, why didn't it die? What saved this star from total destruction? A supernova imposter. Astronomers now classify the 1843 event as a supernova imposter. A rare kind of outburst that mimics a supernova, but isn't one. In a real supernova, the core of a star collapses, forming either a neutron star or a black hole. But in Eta Carinae's case, that core collapse never happened. Instead, only the outer layers of the star were violently blown off. It was like a pressure cooker exploding, but the engine inside was still intact. Possible reasons it survived. So what caused this massive eruption if it wasn't a supernova? There are a few leading theories. Stellar instability. Massive stars like Eta Carinae are extremely unstable. Radiation builds up and pushes outward until the outer layers violently explode. Companion star interactions. Eta Carinae is part of a binary system. The gravitational tug of its companion star may have triggered the eruption. Merger event. Some scientists believe that two stars actually collided or merged, releasing massive energy without destroying the final object. Each of these scenarios could explain why the star nearly died, but didn't. Today, Eta Carinae still burns brightly, but it's dangerously unstable. It may have survived in 1843, but it's living on borrowed time. One day, it will explode, and when it does, it might be the most spectacular event our generation ever witnesses. What makes Eta Carinae so dangerous now? For your channel Core of Space, written in an engaging, cinematic style. It survived a massive eruption. It's one of the largest stars in the Milky Way. And astronomers believe it could explode any time now. But why is Eta Carinae considered one of the most dangerous stars in our galaxy, even today? Let's find out. It's massive and unstable. First, size matters. Eta Carinae is estimated to be up to 100 times the mass of the Sun, and 5 million times brighter. Stars this massive live short, violent lives, and end in spectacular explosions. But Eta Carinae is even more unstable than most. It's a luminous blue variable, a rare type of star known for intense outbursts and mass loss. It's literally tearing itself apart from the inside. Its outer layers are held in check only by a delicate balance of gravity and radiation. And that balance is failing. It's near the end of its life. After the Great Eruption of 1843, Eta Carinae has continued shedding mass through violent stellar winds. Astronomers believe it's in the final stages of its life, right on the edge of core collapse. When the core finally gives in to gravity, the result could be a hypernova, a super-powerful supernova that could outshine the entire galaxy for days or weeks. And some scientists believe it could even form a black hole instantly. This isn't science fiction. It's a real and active threat, just waiting to happen. Could it harm Earth? Show animation of gamma-ray bursts and Earth's position versus Eta Carinae. A common question is, could Eta Carinae hurt us? The short answer is, probably not. It's around 7,500 light-years away, which is far enough to protect Earth from physical damage. But if it produces a gamma-ray burst, a focused beam of deadly energy, and if that beam points toward us, it could potentially damage our ozone layer, leading to climate and biological consequences. Thankfully, current data suggests its axis isn't aimed at Earth, so the risk is very low. So what makes Eta Carinae so dangerous now? Its mass, its instability, its ticking clock. It's a star living on the edge, and when it finally explodes, it could be one of the greatest shows the sky has ever seen. Could Eta Carinae emit a gamma-ray burst? Written in cinematic documentary style for your channel Core of Space. It's one of the most massive, most unstable stars in our galaxy. And when it explodes, Eta Carinae could release one of the deadliest forms of energy in the universe, a gamma-ray burst. But what exactly is a gamma-ray burst? And could it ever be aimed at Earth? What is a gamma-ray burst? A gamma-ray burst, or GRB, is the most powerful explosion known in the universe. It's a narrow, high-energy beam of radiation, released in the final moments of a massive star's death. GRBs travel at the speed of light and carry more energy in just a few seconds than the Sun will release in its entire 10 billion-year lifetime. These bursts are rare, but when they happen, they can sterilize entire star systems. Could Eta Carinae create one? So, could Eta Carinae produce a gamma-ray burst? Scientists say yes, it's possible. Eta Carinae is massive enough, and it's nearing the end of its life. If its core collapses into a black hole while spinning rapidly, it could form a focused jet of gamma rays, a long-duration GRB. But there's a critical factor: direction. A gamma-ray burst only affects objects directly in the path of its beam, like a cosmic sniper shot. If that beam is pointed at us, we could be in serious danger. But if it's angled away, we're safe. Is Earth in danger? Luckily, current data shows that Eta Carinae's rotation axis is not aligned with Earth. That means even if it does produce a gamma-ray burst, it's very unlikely to be aimed at us. And while GRBs are dangerous, Eta Carinae is also far enough, about 7,500 light-years away, that Earth wouldn't face major effects, even in extreme cases. So yes, it could emit a GRB, but no, it's not likely to harm Earth. Eta Carinae remains one of the most powerful and unpredictable stars in our galaxy. It may go quietly. Or it may explode with a fury unlike anything we've ever witnessed. Until then, we watch, and wait. When will Eta Carinae explode? Eta Carinae is one of the most massive and unstable stars in our galaxy. It shocked astronomers with its Great Eruption in 1843, but the big question remains, when will it finally explode? Today, we dive deep into what scientists think about the star's ticking clock. Understanding stellar lifetimes. Stars as massive as Eta Carinae live fast and die young. Compared to our Sun's 10 billion years, Eta Carinae's total lifespan is only a few million years. Right now, it's in the final, unstable phase, burning heavy elements in its core. When a star runs out of fuel for nuclear fusion, gravity takes over, and the core collapses, triggering a supernova explosion. Signs Eta Carinae is nearing explosion. Scientists observe Eta Carinae closely, tracking its mass loss, brightness changes, and high-energy emissions. The star continues to shed mass through powerful stellar winds, and its brightness fluctuates unpredictably. These are signs of a star under extreme stress, a ticking time bomb. But predicting the exact moment of explosion is incredibly difficult. It could happen tomorrow, or it might take thousands of years. Why we can't know the exact time? Predicting supernovae is one of astronomy's biggest challenges. The final moments before a star explodes happen quickly, sometimes in days or hours, but the signs before that can last centuries. Eta Carinae is a complex binary system, adding more uncertainty. Interactions between its stars can delay or accelerate the process. So even with the best technology, we can only estimate, not pinpoint, when the explosion will occur. Eta Carinae's explosion is inevitable, it's just a matter of time. When it happens, it will be one of the most spectacular cosmic events ever witnessed. For now, we watch the skies, waiting for the moment this giant star finally gives its last light. What an Eta Carinae supernova would look like. Eta Carinae is a cosmic giant, massive, unstable, and on the brink of a colossal explosion. But when it finally goes supernova, what will it actually look like from Earth? Let's imagine the spectacular, terrifying, and breathtaking event that could light up our night sky like never before. The initial explosion. The supernova explosion of Eta Carinae would unleash an unimaginable amount of energy. For a brief period, it could shine as bright as the full moon, easily visible during the daytime. The shockwave from the explosion would send vast amounts of gas and dust racing outward, creating brilliant light shows and expanding nebulae. This event could last for weeks or even months, slowly fading as the explosion's remnants spread across space. Night sky impact. At night, Eta Carinae's supernova would dominate the sky. It would outshine every star, except for the moon, becoming a dazzling point of light. Possibly even visible during the day for several weeks. Ancient civilizations recorded similar bright supernovae, which became myths and legends. For modern-day sky watchers, it would be a once-in-a-lifetime spectacle, visible across the entire southern hemisphere. Scientific opportunities. A supernova this close would provide astronomers with an unprecedented opportunity to study the death of a massive star in detail. Scientists could observe the explosion's evolution in real time, tracking shockwaves, element formation, and neutron star or black hole birth. Instruments like the James Webb Space Telescope, Chandra X-ray Observatory, and Earth-based observatories would be trained on Eta Carinae non-stop. While Eta Carinae's supernova might be centuries or millennia away, imagining the event helps us understand the power and beauty of our universe. When it finally explodes, the night sky will never be the same. Eta Carinae is one of the most fascinating and mysterious stars in our galaxy. From its violent Great Eruption in 1843 to the ongoing battle it wages within itself, this cosmic giant continues to captivate astronomers and space enthusiasts alike. What makes Eta Carinae truly remarkable is not just its size or brightness, but its unpredictability. It's a star living on the edge, constantly balancing between survival and spectacular destruction. We have learned that the 1843 eruption, while incredibly powerful, was not the end. Eta Carinae endured and still shines, though in a fragile state. It is now a ticking time bomb, a star nearing the end of its life, poised to explode in a supernova that could outshine the entire Milky Way. The possibility of a gamma-ray burst adds another layer of cosmic drama, a reminder of the immense power stars like Eta Carinae hold, and the delicate dance of life and death in the universe. But despite the potential dangers, we are fortunate. Eta Carinae is thousands of light-years away, and while its eventual explosion will be a breathtaking spectacle, it is unlikely to harm Earth directly. As we continue to study Eta Carinae, it teaches us about stellar life cycles, the forces shaping galaxies, and our place in this vast cosmos. The story of Eta Carinae is far from over. Scientists watch the star carefully, ready to capture every moment when it finally gives its last light. And when that moment comes, it will be a spectacular cosmic event, one that will inspire awe and wonder for generations to come. Until then, we wait and watch the skies, reminded that even the mightiest stars have their limits, and their stories are written in light years and explosions. This is Core of Space. Thank you for joining this journey to the heart of one of the universe's greatest mysteries. Don't forget to subscribe and hit the bell icon so you don't miss the next cosmic event. Until next time, keep looking up.